Our next speaker will talk about challenges and possibilities to chase DNS abusers. Please, Raffaele, Sommese, the mic is yours.
Thanks a lot. So, I'm Raffaele. I'm an assistant professor at the University of Twente, and this talk today is a bit of a thinking process on the kind of data that we need to find, for fighting DNS abuse. And here with DNS abuse, I mean mainly namespace abuse, even if, as we discussed yesterday, sometimes the content of the zone can affect the operation even of the domain name. So, okay. So why this presentation at OARC? OARC is not a place about naming, but is mostly a place about operation. However, there are several actors here that are basically involved in the fight against namespace abuse. And I often discuss of the data needs for fighting DNS abuse, but data at the end of the day needs to come from operators, and only operators know how to design this data sharing or why, for example, they cannot share. And also here I will introduce some nice byproduct and fun measurement orchestrator that we need to get basically this result and discuss about these data needs. So in the previous fall, we wrote this paper. It's called Dark DNS, Revisiting the Value of Rapid Zone Update. You can find the paper online. The important bit here is that by leveraging certificate transparency log, we demonstrated that we detect 42% of newly registered domain name before they appeared in SIDZDS. So we can detect domain name before they are publishing by ICANN through the SIDZDS mechanism in the public internet. And this basically gives us the opportunity of fighting abuse in a quicker way, because we can learn of this domain name quicker. And this is more or less around 76K domain per name, 76,000 domain per name, and it's around 1 domain per second that we are able to detect with this approach. And the most interesting bit of all this aspect is that 1% of these newly registered domain never appear in the next SIDZDS snapshot. So these domains are completely invisible to security researcher, are completely invisible to threat intelligence feed, because basically they are not in this snapshot. And I mean, you can detect some of them with passive DNS, but sometimes these domains even don't show up in passive DNS, so they are completely invisible. And the part is that, of course, these are predominantly malicious because there is no good reason for having a domain name that shows up for less than 6 hours. And we saw that, for example, half of these 1%, so 0.5% of these domains die within the first 6 hours of their life. And the paper was a nice paper, but it was a scientific paper. So we did the analysis. We tried to analyze this operation in a post-mortem scenario, so meaning that we looked to the zone, we looked at the zone after the domain died, and we tried to figure out basically what happened to these domain names and if we were able to detect them before they died. However, being able to block these domains ahead of time may help, for example, a security researcher, a public resolver, to avoid that this domain leverage, for example, long NS caching in public resolver. So when they get deleted, you can still resolve this domain because they may have like cached somewhere. If you are able to block them, so if you have a signal that tells you block these kind of domain names, this may be useful to prevent further abuse of these domains. And how we can detect them as soon as they die, it's a bit of a challenge in terms of operation because, first of all, we need to measure these newly registered domain names. And the things that we come with is that let's measure them every 10 minutes for the next 48 hours. Every 10 minutes here because it was a balance between the kind of strain that we put on the infrastructure and also the fact that we don't have an infinite resource for measuring this domain name. And we do A quad day NS at top-level domain, meaning that we query the top-level domain. We don't leverage the recursive resolver to do the resolution. So we know that the domain expired. We know that domain goes in an X because the top-level domain is telling us, and MX record because we thought maybe that may be useful for detecting kind of mail abuse. And after we see 3 NX domain at TLD level, we issue another RDAP request. So the first RDAP request, we issue 2 RDAP requests. The first RDAP request is issued at the creation of the domain name, so when we detect the domain name for the first time. And the second RDAP request is issued when we know, basically, that this domain is becoming an X domain for 3 times, so it's likely to be deleted. And then we look to the RDAP status for response. And what we found is that someone is holding back these domain names. And most of the cases you find are server hold or client hold. That is a likely indication that it's abuse. It's not certain, because it may be like that just the registry or the registrar are performing investigation, but it's a good indication. And to get to this point, it was a bit of a challenge in an operational way, because we had to fetch basically the certificate transparency log in a live way. We need to extract the domain names from certificate transparency log. We need to join this feed of domain names with the sysadds zone that we download as part of the OpenIntel project, filter out domain that do not appear in the zone, schedule DNS measurement every 10 minutes, schedule RDAP measurement, store all this data, having a sort of real-time data processing. I used Apache, Kafka, and Flink to have basically this feed and this status going on, detecting that these domains are in server hold or in client hold, and then basically publish this feed somewhere. The nice things of all of this is that, so the bad things of all of this is that this requires us to generate more than 400 DNS queries per second. The nice things of these is that we get some nice byproduct as live stream. And the nice byproduct that we get as live stream, it's the list of newly registered domain names detected from city logs, the list of confirmed newly registered domain names. That means when we look to the RDAP, we have like an indication that this domain is indeed a newly registered domain names, because there is like a corner cases where Certificate Transparency Authority can issue certificate for domains that are not existing, and this is a very rare case, but in case they have like the caching of the verification of the domain name, they can still do up to 1 year. So that's the reason why we need like this double feed also of confirming with the RDAP. And we get newly registered FQDN, so if a FQDN that we learned from Certificate Transparency Log belongs to a domain that is newly registered, it's also a newly registered FQDN. And out of these, we have this list of measurement for the AQA, NS, MX, every 10 minutes for the next 48 hours, list of FQDN, list of certificate as stream, list of certificate domain as a stream. And given that I was there, we also implemented the measurement for every certificate that gets issued. And this is publicly available data as best effort. The only thing that I ask is that it's only known for profit. And there is the instruction on how to use this data, but if you want to play this data, if you want to create something that is nice and can enable threat intelligence over this data, please do, and please reach me to tell me what you found out, basically. And then the question that starts to come to me is, isn't there a better way? So this requires a lot of measurement of DNS infrastructure. This requires a lot of queries towards the RDAP ecosystem. Can we do better? And the point is that DNS, it's a pool protocol, meaning that every time we want to know that something in DNS changed, we need to query the DNS ecosystem for that. And there was this concept a while ago that was called rapid zone updates. It was a concept introduced for .com, for VeriSign. And basically the concept was every time domain gets updated in the zone, you can subscribe to a sort of public feed and get that information that a new domain has been created, that a name server has been changed, and so on. So it's a sort of signal for every update in the zone. If you think about the certificate transparency log are doing the same thing. In certificate transparency log, we log every pre-certificate, and some of the X509 final certificates will get published to the internet. And that enabled a lot of security research. And there was a project that was run by Warren and some other folks that was called DNS Transparency that was trying to argue exactly for this argument. And the reason why I think this is really important is we saw 2 presentations before. One was on DGA and another one was on lame delegation. If you can detect changes on the zone, for example, you can identify hijacking, and you can identify cases where people leverage this lame delegation to create harm. And you can leverage before they do harm. If you leverage passive DNS, it's great. It's a great resource. But you leverage that before after they have done harm. And that's the main challenge. And also detecting, for example, early removal of domain names. As I said, this may be helpful for public and private resolvers for example, evicting from cache these domains and avoid that the fact that the domains are still in cache, they can do harm. These things of having certificates that are issued for domains that are not existent anymore. We can enable a mechanism to revoke certificate if the domain expires. Because there is all this certificate laying around when a domain expires that are still valid and can still make harm towards someone. And we can build better machine learning model to detect future threats as one of the GA that was shown before. And in general, I think it's add whatever case let you to monitor the DNS continuously. And the other question that I have is that, will this be enough to mitigate abuse? And the answer is probably not. Okay, the answer probably is we will not manage to fight abuse and to get rid of abuse with just this data. And the truth is that we may need to go beyond just the information that are stored in the zone file. And with beyond DNS, I mean there are 3 parameters that you can consider, and it's where the abuse happens. That means if you can expose registrar that consistently facilitate this kind of abusive registration, you can really create a mechanism where a security researcher and a security firm can basically enable this identification of bad registrar and marking basically these domains as maliciously registered. And the WHO, of course, I mean, GDPR complicated all this matter because GDPR said all the PII information that is in voice or RDOP should not be there. You should hide them, and you should create like all this crazy system to access to every single domain name information. But the truth is that as a security researcher, we don't care that the domain name is registered by random Joe. We care that that domain name is registered by the same unique identifier of another domain name. So if we track that there is a malicious domain behavior on a certain domain name, we can basically apply the same consideration to all the domain name generated by the same unique identifier. And the truth is that, sure, they may still lie. There may still be the cases where if you don't do enough KYC, if you don't check enough that these persons are what they say they are, you may still find that basically they lie, they provide incorrect information, and at the end of the day, you are not able to track them. But we can sort of follow the money. So we can create a unique identifier that's based on the payment method, for example, of the domain name. And that will make basically their life a bit more challenging. And the truth is that, will this solve the problem of abuse? Probably not completely, but at least we try to make their life harder and ours easier, because we can easily track this kind of behavior across the DNS ecosystem. We don't need that every registry needs to relearn the lesson of another registry for detecting the same kind of abuse, and the same goes for registrar. Currently, there is no information exchange that is going on, and the one that exists is very, very hard to implement due to all the legal constraints that are around. And again, they may evade everything by using fake credit card, fake identities, but let's make their life harder. And I'm not saying this should be like a system open to everyone. I know that if I say a certificate transparency log, people will think, oh, you want to publish all this data on the public internet. No, I'm not arguing for that. I'm arguing that this system should create zone of trust where this information can be shared and design basically mechanisms that enable the anonymization of this information without violating the privacy of the users. And the alternative is that we keep playing a sort of cat and mouse game where the abusers continuously escape our detection, and we need always to build new technique, and we need always to put a lot of effort to detect these kind of threats. And with this, I'm open to accept questions.
We have plenty of time for comments.
Yeah, people, this is a strange crowd for being quiet and not commenting. All right, so Hazel asked more of a comment than a question. I wonder if it might be interesting to combine the CT-based domain detection with the machine learning-based DGA domain classification from the previous talk and seeing how the registration and lifetime behaviors of these domains correlate with the different hypothesized attributions to the threat actors.
That's definitely a good suggestion, and that's one of the reasons why I'm trying to make this data public, available to the community, and I hope that people will use exactly for this purpose, exactly for trying to identify this kind of behavior and try to track the users that are perpetrating this kind of behavior.
Right. More tools is better. There's another one, but I can let you want to go ahead?
Hi, Andrew Campling, 49 Consulting. Just picking up on your point about the sort of know your customer, I do think there's a strong case for identifying which organizations don't have effective know your customer processes, and then, dare I say it, have the threat feeds automatically score them very low for reputation, irrespective of who the registrant is. If they don't know who the customer is, assume they're malicious. And ideally, that should drive better behavior, because who wants, if I'm a legitimate user, why would I want to have a poor reputation score? So I'll go to somewhere that has good processes. And I wonder what your thoughts would be on, can we use those sort of systems to drive up good behavior?
I completely agree. I mean, at the end of the day, that's what happened with the certificate ecosystem. In the introduction of certificate transparency log, we were able to detect a lot of CAs that were perpetrating shady behaviors, and we were able basically to establish then the good manners of being a CA. So I hope that if we get to a consensus of building such a kind of system to expose this kind of information inside the DNS, we may get to the point where we can expose this kind of registry that do not perform KYC, do not perform the due diligence of detecting a malicious registration and having, for example, a sort of scoring system, and say, okay, you know what, at least for the first 24 hours of the existence of this domain name, the time that the threat intelligence does all their analysis, we'll block them because we are not really sure that these are good domains.
Yeah.
So one more question from Patrick Mevzek. Says, with the NIS2 and other regulations, more and more registries going thin, so no registrant info at the registry, which has always been the case with .com. Also, RDAP is not available and never will be for all TLDs. Who will enforce the service or access you're talking about?
I mean, the problem of RDAP is that you still have, you get some information out of the system, but you still get a partial view, because you don't get information about who is registering the domain name. You can do the things of saying, oh, this registrar is behaving like in a weird way, but other than that, you cannot really do a lot. And the main problem that exists, the main problem that we saw by looking at these domain names, that these domain names really hide behind legitimate infrastructure. So they host their service on Cloudflare, they host their service on DigitalOcean or on whatever kind of legitimate provider. So it's really hard to track who these people are, and that's the challenge.
Any more questions, comments? So, Raffaele, thank you very much.
Thanks a lot.